Good morning, good afternoon, and good evening. My name is Håkan Silfvernagel, and today I'm going to be talking about how you can perform machine learning in the browser using TensorFlow.js. But before we start, just want to say a thank you to our sponsors. So our sponsors for this event is ScriptRunner, it's DQ Global, Proxima 3, Redspire, Agilysys, and Hitachi Solutions. And before we start, I'm just going to say a couple of words about my background. So I work as a manager for AI and big data at a Norwegian consultancy company called Miles. And I'm also a Microsoft MVP in AI. I am an active community member here in Oslo. I'm running the Norwegian.net user group and also the Oslo AI. I'm also running AI42, which is an online AI school together with Eve Party. And if you want to reach me, you can see my social media details on this page here. So the agenda for today is first I'm going to give a brief introduction into machine learning so we're all on the same page. Then I'm going to go a little bit into TensorFlow, and then we will specialize on TensorFlow.js. We're going to have two demos today. One is we will build a machine learning application from scratch using TensorFlow.js, and we will also use an already trained image classifier that we will use in the web. So first off, what is machine learning? Well, a lot of people think that machine learning is something new since it's a very hot topic today here, but if we go back in history, it dates back to the 1950s. So there was Arthur Samuel. He said that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And we can also say that machine learning is a pattern recognition in historical data. Now, some applications of machine learning is predictions. You can, for example, predict the house price if you have some different features like the neighborhood where the house is situated, the number of rooms, or the year when it was built. You can have recommendation systems that will recommend things for you based on previous purchases. You can have clustering. You can say you can divide a large number of customers into different customer groups so that you can specialize and personalize the information to each customer group. You can also think of image recognition, text recognition, and speech recognition. So one way of machine learning is called supervised learning. And the way that supervised learning is that you have both access to historical input data and also to the historical output data. Based on these two, you can build a machine learning model. And then you can train this model so that it can take new real-time data and then it can give you back a recommendation or a prediction. And we're actually going to make use of supervised learning in our first demo in a little while. But as I said previously, AI and machine learning dates back to the 1950s. So the question is, why is it such a hot topic today? So we have a number of enabling technologies that has made this possible. So one of them is in sensor technology. We have access to cheap sensors that can give us access to real-time data. And we have also big data solutions so that we can do transformation and storage of this data. And we have machine learning algorithms running in the cloud that we can make use of in our own applications. And just for completeness, I would also like to say a couple of words about different languages for machine learning. So the two most popular languages are Python and R. And Python is mostly popular among people with a computer science background, whereas R is more popular among people coming from a statistical or from an academic background. Now, when we know a little bit more about what machine learning is, we can go more deeply into TensorFlow. So TensorFlow is an open source library developed by the Google Brain team, and it expresses its algorithms using something called tensor operations. So I'm going to describe to you in a short while what a tensor actually is. And one of the big advantages in using TensorFlow is that it supports distributed computing. And this can be very beneficial if you're going to do deep learning or neural nets. So a tensor is something that comes from the world of mathematics. So we can differentiate between a scalar, which is only a single real-time number, or vector, which is a collection of scalars, or a matrix, which is like a two-dimensional collection of scalars. And then tensor is just a container that can contain either a scalar, a vector, or a matrix. So if we use TensorFlow in Python, this is an example here. We import the TensorFlow library, and then we start up a new TensorFlow session, and we define two constants. We define A with a value of 10 and B with a value of 32. And then we can print out on the console by running the session.run, and then an operation A plus B. But now we have TensorFlow.js. So TensorFlow.js is a JavaScript library where you can both train and deploy your models both in the browser and on Node.js. So now in our first demo, we will have a look at how can we actually perform machine learning in the browser. So let me switch back. Let me switch over here to the browser. A moment here. So the first thing that we need to find is we need to have some data, and we also need to try to define here a problem. And luckily for us, we have some data here in the form of a JSON file. So in this file, we can see some car statistics. So you can see the name of the car, the model, you can see the number of cylinders, we can see the miles per gallon, and the horsepower, and so on. So the question is here, can we use this data in order to see if we can predict one of these features from another feature? So we're going to focus on the miles per gallon and the horsepower. So the first thing that we would like to do is we would like to load this data into our web application, and then we would like to visualize the data in order to see is there any form of correlation between these two features. So let us have a look here in Visual Studio Code. So here in Visual Studio Code, we can see that we have loaded the TensorFlow JavaScript library, and we have also loaded the TensorFlow visualization, which is a visualization library that we're going to make use of in our demo. And then we also refer here to a script.js file. And right now, the only thing that we do in our script.js file is we write out on the console log hello TensorFlow. So let us run this in the browser. So if we run this, we can see that the TensorFlow library has been loaded, and we can write out hello TensorFlow. And now, the first thing that we would like to do is we would like to load this data. So first, let us define here a function that is called getData. So in this function, what we do is we fetch this JSON file, and then after that we extract the miles per gallon and the horsepower, because that's the data that we're interested in. And then we also filter out possible null values because we don't want to have them. And then we return the cleaned data. So next thing is we would like to be able to plot this in a scatter plot in order to see if there is any correlation between those two data. So let us add a new function. So in this run function, what we do is we get the data, and then we map the data so that we have on the x-axis we will have horsepower, and for y values we will have the miles per gallon. And then we can just make use of this TensorFlow visualization component, and we can specify that we want to render a scatter plot. And on the x-axis we have horsepower, and the y-axis we have miles per gallon. And then we will add more code beneath this as this example continues. We also add an event listener so that we will run this function when the DOM content has been loaded. So let's save this, and let's run this in the browser. So now what we can see here, without us doing almost nothing here, we could actually get this scatter plot here. So we can see here that on the x-axis we have horsepower, and then on the y-axis we have miles per gallon. And as we can see, there seems to be some sort of correlation, and that's a good thing for us, because if these data points would have been scattered all around the plot, that would have meant that there is no correlation between the data points. So there is nothing for a machine learning algorithm to learn. But now we can see that there is some sort of structure in this data that we can learn, that we can train our machine learning algorithm so that it can learn from that, and then we can feed it with new data and get some new predictions here. So the first thing here that we would like to do is we would like to define a model architecture for our machine learning model. So in machine learning term, a model architecture is what kind of algorithm should this machine learning model use in order to compute its answers. So machine learning models are algorithms that will take one input and it will produce an output. So in this case, we will use something called a neural network. So here the algorithm is a layer of neurons with weights that will govern the output. And during the training process, the algorithm will learn the best values for these weights. So let's add function here in order to create our model. So let me go back to Visual Studio Code. So in this function, we define a sequential model. And this is one of the most simple models that we have in TensorFlow.js. And it's called sequential because its inputs flow straight down to its output. And there are also more complex models that can enable both multiple input and multiple output, and also branches. Then after that, what we do is we call model.add. So this will add an input layer to our model. And this input layer is connected to something that we call a dense layer. So a dense layer is a type of layer that multiplies its input with a matrix that we call weights, and it also adds a number that we call a bias to the result. And this is the first layer of the network. So we need to specify both the input shape, which in this case is 1, and this means that we have one number as an input, and that is the horsepower of the car. And then we need to define the units, which sets how big will this weight matrix will be in this layer. And here we set it to 1, so that means that there will be one weight for each of the input features of the data. And then we create an output layer where we set units to 1 because we want to have one number as the output. Next, we need to create an instance of our model in order for us to use it. So let's go to our run function. So here, the first thing we do is we create our model, and then we are using the TensorFlow visualization component in order to show us a model summary. So let's run this in the browser. So we can see our scatter plot, and then we can also see a model summary. And here we can see the layers, how many layers we have, and the output shape, and how many parameters we have, and if they're trainable or not. So this is very similar to what we would have seen in our Jupyter Notebook. Next up is we need to prepare the data here for training. And one thing that we need first to make sure is that we need to be able to convert our data into tensors, because TensorFlow is only using with tensors. So what we'll do is we'll convert our data into tensor, but we will also perform some best practice. So in machine learning, so that is shuffling and normalization. So let us add the function here, convert to tensor data. Let's go to our Visual Studio Code. So what we do here is first we do some shuffling of the data. And the reason why we do this is that when we do training of the data, we will divide our data into different smaller batches. And when we train, we want our batches to be as representative as possible of the whole data set. And when we do this shuffling, we will get data from all across the data distribution randomly. And this has some advantages. So one of them is that now we reduce the risk that our machine learning model will learn things that are only dependent on the order of the input data. And in addition, it's not so sensitive to structures in subgroups, because it could be that maybe there is, for one or the other reason, there could be a high horsepower for the first half of the training data. And that would be a relationship that would not be representative for the whole data set. Then we can make use of a predefined function here, tf.tensor2d, in order to convert our data into tensors. So we map horsepower to input tensor and the result, the miles per gallon, to something that we call label tensors. And then what we do is we do some normalization. And the reason why we do the normalization here is because many machine learning models, they are designed to work with numbers that are not so big. And in this case, we're using something called a min-max scaling. And in short, what we do is we find the max and the mean, and then we subtract the minimum and we divide with the max minus the min. So then we get the normalized inputs and normalized labels. And then we return all of this together with this max and mean that we've found. And the reason why we want to return it is because when we have done our predictions, we need to be able to scale our prediction back to the original value, so it actually makes sense to us. So next, we need to be able to train our model. So let us add a function here for training our model. So before we can do that, we need to compile our model before we can train it. And we also need to set some parameters for our compilation. And one of them is what optimizer we want to use. And an optimizer is an algorithm that will decide on the updates to the model. So when it sees new examples, how will it update the model? So there are many types of optimizers in TensorFlow.js, and here we've picked the Adam optimizer because it's quite effective and it requires little configuration. And the second thing that we need to define is the loss function. And this is a function that will tell us how well the model is doing on learning each of the batches. And here we are using the mean squared error in order to compare the predictions made by the model with the true values. And then next, we pick a batch size and also the number of epochs. So the batch size refers to the size of the data subsets that the model will see on each iteration of the training. So common batch sizes can range all between 32 to 512. And there isn't really any ideal batch size for all types of problems. So this is setting the batch size is a little bit of science in itself. But here we go with 32 as the batch size. And the epochs is the number of times that our model will be looking at the entire data set. And here we will take 50 iterations through the data set. And then finally, we start the training loop by calling the model.fit with our inputs and our labels and some more parameters. And we can also, what we've also done here is we've defined a callback where we're using this TensorFlow visualization component in order to visualize on each epoch we can print out the loss function and the mean squared error. And in this way we can monitor the training by plotting charts both for the loss function and the mean squared error. So now it's time to do the training, so we need to add some code to our run function. So here what we do is we first convert our data to tensors, then after that we extract the inputs and the labels, and then we train our model, and then we just print out on the console log that we're done training. So if we go back to the browser and we run this, then we can see here we can see on each epoch, remember we set the number of epochs to 50, we're printing out the mean squared error and the loss function. And we want this to be as small as possible. So now we can see that it's done training, and then we can see here that is 0.05, for example, in our loss function here. So let's say that we're satisfied with this. Then the next is we want to give our model some new data that it hasn't seen, and we want to make some predictions. So what we'll do is we will input a range of numbers of horsepower and then see what miles per gallon our model will predict. So let's add a function here where we can test our model. So what we do here is first we generate 100 new examples that we will feed into our model. And then we call model.predict in order to get our predictions. And then we do an unnormalization. So that was the reason why we wanted to save this input mean and input max and so on. So we can convert our data back to the original scale. And then after that, we render here in the scatter plot, we can render the model predictions versus the original data to see how well our model is performing. And then the only thing that left to do is we need to call this function in our run function. So let's go back here and like this. So here we just do testing of our model. So let's run this in the browser. So I should also say, since this is just an example, we're doing this this training of our machine learning model every time we run our example here. But in real life, you wouldn't do that. Instead, you would monitor your model so that you can see if it deviates too much. Then you need to do retraining of your model. But otherwise, you can just keep it as it is. But now we can see here. So this is our real data, and this is the predictions. So we can see that it tries to predict, but it predicts using just a straight line. So it can't take into account that this data seems to have some sort of unlinearity in it. So in order for us to take that into account, we need to change our model a little bit to take into account this non-linearity. So let's go back to where we define our model, and let's define a new model instead. So if we go back here to the place where we are defining our model, it is over here, and then we can comment this thing out. So here we are adding a different type of model here, where we add more layers here that will take into account this non-linearity of our problem. So let's save this, and then let's go back to the browser. So here we can also see that our model has lots more number of parameters. So for example, here it says 4,160 parameters that can be trainable. And we can also see here that in our loss and our mean square error, it reaches a low mean square error and a low loss function a lot earlier than what our previous function did. And we can also see that it is a lot lower, also it's 0.01. And as a result, we can also see that this model is much better in doing our predictions than our previous model, which was trying to do a linear prediction. But here we can take into account this non-linearity. So that's it for our first example here. And what I would like you to take away from this is that what you can do now is you can do some preliminary data analysis by using this TensorFlow visualization component, and then you can actually do both training and testing of your model, and you can also run predictions in the browser. And as you could see also from the code, there is not so much code that is involved. So let's go back to our slides. So now we've had our demo here of TensorFlow.js. So what we can also do, we can also convert an existing model. So we can, for example, convert an Keras H5 model to the TensorFlow.js layers format. And we can do this in two ways. Either we can use it from the bash or the command prompt. So then there's a TensorFlow.js converter command here that we can use, or we can use it from the Python API. So in Python, what we do is we import Keras and we import TensorFlow.js and TensorFlow. And then we are loading our, in this case, it's a mobile net model. And then we're only using TensorFlow.js converters save Keras model. And then we can save it in the TensorFlow.js layers format. And then in our JavaScript application, we can import TensorFlow.js, and then we can load our layers models by using await TensorFlow load layers model. And then we can just use it. And we will have a look at this in our second example in a short while. So, one of the questions you might ask is, why would we want to use TensorFlow.js? So one reason here is that by using TensorFlow.js, we can already use the tools and the languages, in this case JavaScript, that we already know. So we don't need really to learn another language like Python or R or new libraries or Jupyter Notebooks or anything. And in addition, all of this can take place on the device, so you don't need any round trip from the client to the server. And that can also lead to a higher security because you don't have run into the risk of a man-in-the-middle attack, since the user data is local and also all the computation will take place also locally. And in addition, you will be able to enable your users to use the browser application as a highly interactive and easy to use user interface. And you also have easy access to sensors like the webcam and the microphone, and you can take advantage of the GPU. So as I said, you have some different ways of working with TensorFlow.js. Either you can run existing models, so we'll have a look at that soon. So there are already existing models that you can just take as is and you can run it, or you can do some retraining of existing models, or you can develop your own machine learning models using JavaScript, as we did in our first example. So here are some examples of some existing models that we can make use of for image classification, for object detection, for model segmentation, and so on. So in our next example, we're going to use an image classification model in order to build an image classifier. So let me switch back to the browser. And let me load this. So the way that this works is you first select an image that you want to classify, and then after that you select the model here. So we will select our mobile net model, and then after that you run a prediction, and then you can see here that with 99.9% it predicts that this is a strawberry. So let's have a look at what we needed to do in order to build this image classifier. So let me switch over here to Visual Studio Code. So now we're in Visual Studio Code. So here we can see that this is the user interface for our image classifier, and here we're selecting which model we want to use. And the interesting part is here that we are loading our TensorFlow JavaScript library, and we are also doing our machine learning work here in predict.js file. And we have also something called ImageNetClasses.js that I will explain in a short while. But if we go to our predict.js file, you can see that here is the image selector. So when we select an image, we read the image into memory. And then when we select a model, we are calling functional load model with the model name as a parameter here. And then you can see here on our left here that we have a directory structure so that we can, for example, in this case, the name was MobileNet. So then we go into the MobileNet folder, and here is the model.json, which is the result of this conversion that I was showing you a couple of slides ago. So what we've done is we've converted the Keras H5 model MobileNet into a layered TensorFlow.js model. And the result of that is both a number of binary files and also a model.json file that we can use. So we only need to use TensorFlow load layers model in order to get that model. And then when we do predict, we do some pre-processing of our image so that we can get it into the TensorFlow format. And then after that, all we need to do is call model.predict with our TensorFlow or with our tensors, and then we can get the result back, the predictions. And then we just take the top 5 predictions and we print them out. And in this case, what you get from this image classification model is you get the probability, and then you get an index into a class file. So this index is into this file here, the ImageNet classes. So it's just an index into the text representation of what it is predicting. So that's all the code that we actually need to write in order to get this to work. So let me switch back over here to my presentation here. So now in my last part of a presentation, I would like to talk a little bit about some more real-world examples. So one of the examples is a tool called Uber Manifold. So this is a visual debugging tool that is using TensorFlow.js that is used by Uber. And you can read more about this on this GitHub link that you can see on the slide. Another example is Airbnb identity document detection. So when you want to rent out the property using Airbnb, then you might risk uploading some image with some sensitive information, such as your driver license or maybe your passport. So what Airbnb is using is they're using TensorFlow in the client, so that when a user is trying to upload a profile picture to the Airbnb websites, then this TensorFlow algorithm will warn the user that this picture contains sensitive information. And then a third example is from the world of music. So this is from Magenta, and they are using machine learning models in order to generate music. So with that said, I hope that you've enjoyed this session. So I also have some references for you if you want to learn more. So we have the TensorFlow official documentation, and we have also some courses on Coursera, like Introduction to TensorFlow. And if you want to know more about this image classification example, there's a Deep Lizard YouTube video series, or you can go to Code Labs, where there are many tutorials that you can learn more about. So if you have any question or any comment, you can always reach me on Twitter. My name there is Agrevlis, or you can reach me on email on the email address that you can see here on this slide. With that said, I would like to wish all of you a great conference, and thank you so much for coming to my talk. Thank you so much.